Algebra 1, Day 98. Today we're going to continue talking about factoring quadratics. Now, factoring quadratics is a pretty easy thing to do because it happens the same exact way every single time. What does that mean? That means that you should always follow the same exact steps no matter what kind of quadratic factoring you're doing. All right? So let's go ahead and jump into it. So when factoring out trinomials, you need to factor out any greatest common factors or x's before factoring completely. So for example, or negatives. For example, I see here that this guy has a negative. Now, whenever you come to the STAR test, they are going to leave the negative in there, which drives me crazy. But that's okay. That is improper math. You should never, ever, 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 ever write something like this. This negative should always be factored out. That coefficient of x should never have a negative attached to it. Okay? But just remember that on the STAR test, they may do that because we have people who don't know math writing the test. So let's go ahead and take a look at this one. I see here that they don't have any numbers in common. However, each one of them does have a negative. So I'm going to go ahead and factor out my negative. All right, so now that I've done that, I'm going to go ahead and multiply A times C. I need two numbers that when multiplied together will give me positive 24. However, when they are added together, will give me positive 11. So I'm looking for two positive numbers. So I'll just start at the beginning because I have no idea what these numbers may be. And it looks like they are positive 3, positive 8. Now I'm going to take my equation and I'm going to rewrite it. Except I'm going to break apart that middle term. Now I'm going to go ahead and I'm going to factor from just the first set. Remembering that in this particular set, you should always, at minimum, have an x to factor out. And 3x divided by 3x is not 0. It doesn't disappear. It becomes a 1. Let's go ahead and factor out from the second step. Now I'm going to go ahead and I'm going to verify that the insides of these parentheses are exactly the same. And they are. So now I can go ahead and combine like terms. Noticing that I maintain my negative here on the outside. This is now completely factored. Had they have asked me to solve this, if it had been equal to 0, I would have had two separate equations because we can split them apart. And of course, I can do opposite over coefficient in order to find those two zeros. Let's go ahead and take a look at example number 2. So for this particular problem, I see that they all have a 5 in common. So I'm going to go ahead and I'm going to take that 5 out and I'm going to divide everything else by 5. Now I have something that's a little bit easier to work. I'm going to go ahead and multiply my new A and my new C together. And I need two numbers that will multiply together will give me 10, but however will add together to give me 11. And those are pretty simple to find, 1 and 10. Now I can go ahead and rewrite my equation. And I'm going to split apart that B value. Now I'm going to go ahead and factor from just the first set. Always, I should have at least an X getting factored out. Now I'm going to do the second set. Now that I've done that, I'm going to verify that the insides are exactly the same. They are. So I'm going to go ahead and combine like terms. Now, for the purposes of this, which I forgot to do for the very first example, we do want to make sure that they are exactly the same. Now, what I can do is I can go ahead and I can graph each one of these. So I'm going to call this F1. This will be my original one. I'll go back and start on problem number 1. Negative 6x to the power of 2 minus 11x minus 4. And look at that. That's what it looks like. But let's go ahead and graph the one that we believe to be our answer. So I'll call that FA1. And we said that it was negative 3x plus 4, close parentheses, multiplied by 2x plus 1, close parentheses. And look at that, it lays directly on top of it. That tells me these are exactly the same and this is correct. Now, what about that second one? Well, let's go ahead and graph that one as F2. So 5x to the power of 2 plus 55x plus 50. All right, so it should look something like this, right? So let's go ahead and press tab, and I'm going to go ahead and choose my answer for number 2. And that is going to be x plus 10 multiplied by x plus 1. Now, I can already see here that my answers, my zeros, solutions, should be negative 1, negative 10. Oh, whoops. Hold on. Sorry, guys. I did not type in my 5. There we go. Now they lay exactly on top of each other, and we know for sure 100% that this is the correct answer. And again, if I wanted to go ahead and split these apart and solve for them and tell me where they touch the x-axis, where their x-intercepts are located, I would just have to do opposite over coefficient. All right. Now, we do have special cases of this called the difference of two squares. Always written in this form. The number of terms must be 2, and you must be able to take the square root of A and C. So whenever I see ax squared minus c equals 0, my immediate thought is to look at this number. Can I take the square root and it gives me a whole number? Yes, 9. Now I look at this guy. I can take the square root. It's 6. That tells me the answer should look like this. Traditional factoring will still work on these. So if you don't understand this, if this is something that goes over your head, you can still totally factor normally. Now let's just verify that this is going to be the correct answer. So let's head back over to the calculator. I'm going to start a new graphing page. I'm going to call my original F3. And I'm going to go ahead and type in my answer for number 3. And that's going to be 9x plus 6 times 9x minus 6. And look at that, it lays directly on top of there. So that tells me 100% that this is the correct answer. All right, let's take a look at the next one. So here, I'm looking at these and I'm asking myself, okay, does 25 give me a perfect square root? And it does. It is 5. Does 256 do the same thing? It does. It is 16. Now I want to verify that there is a negative in between them, and there is. So that tells me that my answer should look like this. But let's go ahead and verify this utilizing my calculator. So I'll go ahead and start a new graphing page. Here's what my original graph should look like, with answers located at both positive and negative, 16 over 5. Let's go ahead and type in that answer. Hold on. Let's go ahead and type in that answer for number 4. And we got 5x plus 16 multiplied And look at that, it lays directly on top of it, meaning we did this exactly correct because they are the same. So that is my answer. And my x's should be located at positive or negative 16 over 5. So I want you guys to go ahead and get started on your example questions, and I will see you next time.